example 3 for 2.2 in 30-1 math here is really just sketching what the graph of the square root of an existing function would look like. This is something that we did in the other examples, but it's nice to see the kind of technique all together. The best way of doing this is to identify invariant points, predict the shape of the graph, and then maybe if you want, grab a couple other points just to confirm what your graph looks like. Now, I'm not going to break out a ruler or a protractor here, but the one thing that I am looking for is pretty clearly when is the square root of the function, which I'm going to do in red here. So y equals the square root of f of x. I'll do in red. I'll use another color on the other page there. So the red graph, I am going to look at finding points using our blue existing function, y equals f of x. So anywhere that f of x is equal to 0, which is right here, I'm going to put these points underneath. So 4, 0, negative 4, comma 0 would be on my radical, y equals the root of f of x. So would this point right here, which is negative 3, 1. And then the other point that I'm going to grab, I always like looking at perfect squares, and 0, 4 is on the original graph. So 0, 2 will be on my radical graph. And I think looking at those points, it's pretty maybe simple to identify that those 2 points have to connect. So that arm of my function looks something like that. Now, if we think about the value of the function there, keeping in mind that this point right here is at negative 3, 1, to the right of that point, f of x is greater than 1. So the radical should be underneath the original. But to the left of that point, in between negative 4 and negative 3 for x values, my function is in between 0 and 1. So my radical function should be above it. The one thing that you shouldn't do is don't exaggerate that curve. Don't go out and back, because now you're saying that those x values right here are okay, which they're not. And we'll talk about why that is. If I grab a point, just, a random point right here, that's at negative 6, negative 2, which means logically that should map to negative 6, the square root of negative 2. Try to write that a little bit so it looks at least like what I'm saying. So negative 6, the square root of negative 2. This does not exist because the square root of the negative. So that red graph is the entirety of y equals the root of f of x. Okay, similar on the other one, I'll do it here in green. Y equals the root of f of x. I'm going to use the same technique. I'm going to identify where my function, and whoops, they use a different function notation. We have to learn to get used to that. So I'm going to graph y equals the root of g of x, because the original is g of x in green. I'm going to identify invariant points, which are where my original function g of x is 0 or positive 1. If I wanted to, I could grab another point. So when y is equal to 4, my radical will be equal to 2-ish. I try to get those at least close. And those are really the only points that I think are nice. Now, when I draw this, it's really important that in between here, my green graph is above my existing, and then after it's below, and that's going to be true on the other side as well. All right, these sketches are really testing a couple things to make sure you understand when the radical of a function exists and when it doesn't, and that in-depth understanding that if f of x, or g of x for that matter, has a value in between 0 and 1, then the square root of that value actually makes it bigger. And that's really just due to how decimals behave when we multiply them. But I'm not worried about that. I really want to make sure you understand that the radical is above when the function has a value between 0 and 1. Not including 0 and 1, because it's equal at those points. All right, I'm going to leave that assignment up here. There's just a little correction inside the textbook. 16C should be 26, 6 minus 4 root 2. You'll see that when you get to it. Please do make sure you're checking Google Classroom, though, because we are modifying these quite often.